Hello everyone, I am Thangapan S, 3rd year CSE, and I am here to explain our problem statement. In many developing countries, newborn babies die because hospitals do not have proper incubator. Incubator are very important for premature babies because they provide the right temperature and safe environment. However, in many hospitals, these devices are too expensive, not available, or stopped due to power cut and lack of maintenance. This make it difficult for doctors to give proper care at the right time. We are developing this project for Ladakh condition. Another major issue is that many existing solutions focus on more innovation for awards rather than real world use. This design may look advanced, but they are often difficult to use, repair, or maintain in rural areas. The solution we have developed for this problem is solar powered hybrid neonatal incubator. It works using both solar energy and regular electricity, ensuring continuous operation even during power failures. This makes it highly useful in areas with unstable power supply. Our design focus on being cost effective, easy to use and easy to maintain.
I am Saravnavir. So I will be explaining about the rapid prototyping process of our project. So to develop a prototype, we have used three materials, that is cardboard box, white paper and a transparent plastic sheet. The cardboard box is to define the outer structure of the project, and the white paper is considered as the insulated layer, reflective layer, and the transparent white sheet is considered to be glass through which we can look at the building. So the basic flow of our prototype is to the prototype has a solar panel on the top, and in the top portion of our project we have the baby placing area. So in that area we can place our baby, and that area is completely insulated by using for now it's white paper, but in development it will be used as a insulated wall. So in that insulated wall it will keep the heat from going away from that box, and below the baby placing area we have the heater. So in that heater, the power is provided by battery or the solar panel. So the heater will provide heat to the baby, and the heat gets insulated through the walls. And if the heat gets out, that is the baby gets less warmer, so we'll have the thermostat so that it will turn on the heater and the baby gets warm again. Our main process is to keep it low energy consumption, so we have used that insulated walls so that no needed energy get out of the box and the baby gets uncomfortable. And so the main flow of our project is the solar panel on the top will get the charge, and the charge will be transferred to the battery so that it gets stored in the battery. After storing the charge in the battery, it gets directly to the heater. So if the baby is kept in the right temperature, then the heater gets off, and as the walls are insulated, the heat gets persisted. If the heat does not persist and the heat gets out, so we'll have the thermostat that's on the side of the wall. The thermostat will control the heater to provide heat as well. And in the front we have a small control panel to control the temperature of our project. uh, so the control panel will be used to directly control the temperature of the baby as well, and insulation, and an air vent to control the inflow and outflow of the air. So that's it, that's our prototype. Thank you.
Hello everyone, I am Prajin. Now I am going to explain about usability testing. And yeah, it is mainly about gathering feedback from users. So first, what is usability testing? It is a method where we check how easy and safe a product by asking real users to try it and give feedback. In our case, we tested a baby incubator design. Let's see about methodology. Let me explain how we conducted the testing. So we had four participants, and yeah, they acted like a nurses or healthcare workers. Then we gave them some tasks. First, we asked them to observe the incubator structure. Next, they tried to assessing the inside through hand openings, like how they would handle a baby. Then we asked them to check how easy it is placed and monitor a baby inside. And finally, yeah, they shared their feedback about comfort, usability, and safety. Next, data collection. So how did we collect the data? We used two methods. First one is direct observation, where we watched how they interacted with the incubator. Second is verbal feedback. They told us their experience and suggestions. Next, we see about key insights. What we learned from this testing? First is ease of use. So users said the design is simple and easy to understand, which is good. Next is visibility. Uh, they liked the transparent from front because it helps in continuous monitoring of the baby. Then comes safety perception. So users felt that some improvements are needed in edges, openings, and stability to make it safer. And finally, practicality. They said the design is compact and lightweight. So it is suitable for low resource hospitals. Then recommended improvements are now based on feedback. We suggested some improvements. First, we should improve the placement of air vents so airflow is becomes better. Next, we need to smoothen the edges, yeah, to avoid any injuries. Then we should make the top cover easier to open so handling becomes simple. And finally, we need to strengthen the structure so the incubator becomes more stable. Now conclude usability testing helps us understand real user problems and improve the design. It ensures that the product is not only the functional but also safe and easy to use.
I'm Gokul Krishnan from third year CSE, and now I will explain our iterative design process. In this stage, we focused on improving our prototype through continuous feedback and refinement. Instead of stopping with the first design, we followed an iterative approach where we tested, identified issues, and improved the design step by step. Initially, before improvement, we observed a few key problems in our prototype. First, the front axis was unclear, meaning users were confused about how to open and use the front side of the incubator. Second, the air vents were not clearly visible, which is important for proper airflow and safety. Third, the control panel usage was unclear, so users were not sure how to operate or understand the settings. Based on these issues, we worked on improving the design. After refinement, we introduced a clear and properly defined front door, making it clear and easier for healthcare workers to access the baby. We also made the air vents more visible and well positioned, ensuring better airflow and easier understanding of users. In addition, we improved the control panel by adding proper labels, so users can easily operate the system without confusion. This iterative process helps us transform our design from a basic prototype into a more user-friendly and practical solution. It also shows the importance of listening to user feedback and continuously improving the product rather than assuming the first design is perfect. In conclusion, iterative design plays a crucial role in developing solutions that are not only innovative but also usable, safe, and effective in real-world conditions.
Hello everyone, I am Sanjeev Krishna and now I will explain our iterative testing and refinement process. In this stage, we focused on improving our prototype through a series of structured tests and continuous refinements. Rather than finalizing the design at the first attempt, we followed an iterative approach where we tested the system, identified issues, and gradually enhanced the design for better performance and usability. Initially, during our earlier testing phases, we identified several issues that needed improvement. First, the front opening access system was not clearly defined, which made it difficult for users to understand how to open and operate the unit. Second, the air vents were not labeled or clearly visible, affecting both airflow and understanding and safety. Third, the internal arrangement for baby placement lacked a proper system, were not proper organization, making it harder for users to position their baby safely. Additionally, the solar panel hybrid system were not clearly presented, and the placement of the control panel, battery, and the thermostat caused some confusion among users. Based on the observation, we refined the design step by step. After improvements, we introduced a clear and well-defined front access system, making it easier for users to operate the incubator. We also provided visible and clearly labeled air vents, ensuring proper airflow and better user understanding. The internal chamber was reorganized, offering a neat and a safe space for baby placement. Moreover, we provided the clarity for the solar panel and hybrid system, helping users understand the power mechanisms. Finally, we ensured the proper placement of the control panel, battery, and thermostat, making the system more initiative and user-friendly. This iterative refinement process helped transform our design from initial basic prototype into a more stable, user-friendly, and practical solution. It highlights the importance of continuous learning, feedback, and improvement, ensuring that each version of the prototype becomes better than the previous version. And finally, the conclusion of the project. In conclusion, our project demonstrates how a thoughtful combination of engineering, user feedback, and iterative refinement can transform an initial idea into a practical and reliable solution. Through structured testing, continuous improvements, and careful attention to user needs, we were able to enhance the design's safety, usability, and overall performance. This project not only helped us develop a more effective prototype but also strengthens our understanding of the design process. So, in the initial innovation is achieved step by step through testing, learning, and improving. Ultimately, a solution aims to provide a user-friendly and effective system that can make a meaningful impact in its intended application. Thank you.